Welcome back. Welcome back to the online class of Alpha School Panaparamba. We are discussing the chapter Rational Numbers. Okay. Through this chapter, we already discussed addition, subtraction, multiplication and division of rational numbers. Okay. Today we are going to discuss about the properties of rational numbers. Okay, we have to check 4 properties. Which are they? Look at the board. Closure property, commutative property, associative property and distributive property. These are the 4 properties. Okay, let's rewind. What are these properties defined? First of all, what is a closure property? I think this property is very familiar to you. Okay, what is closure property? If we take any two numbers and perform any operation such as addition, subtraction, multiplication or division, if the result belongs to that particular group, then we can say that that particular group satisfies closure property. Let's go through an example. Consider natural numbers, set of natural numbers. Okay. If we take any two natural number and perform addition. For an example, if we take two numbers 2 and 3, then we add these two numbers, that is 2 plus 3. What is the answer? 5. 5 belongs to natural numbers. Okay. And doing like this, we can conclude that in the case of natural numbers, addition is closed. That is, the sum of any two rational number again belongs to a natural number. So we can say that natural numbers are closed under addition. What about subtraction? Subtraction is not closed. Why? If we subtract any two natural numbers, the result may be negative. For example, 5 minus 7. What is the answer? Minus 2. Minus 2 not belongs to natural number. So we can now say that natural numbers are not closed under subtraction. Clear? Now again, what about multiplication? Multiplication is closed. Why? If we take any two natural numbers, the multiplicating answer or the product that should be belongs to natural number. So we can say that natural numbers are closed under multiplication. But in the case of division, natural numbers are not closed. So these are the primary definition of closure property. Through this chapter, we have to discuss about the rational numbers. So we are coming back to the rational numbers. Let's check the properties one by one. First of all, considering closure property. Okay, and if we take any two rational number, then we add these two rational number. The answer should be a rational number. Is it clear? So we can say that rational numbers are closed under addition. Clear? Now if we take any two rational numbers and subtract these two numbers, the result that should be always a rational number. So we can say that rational numbers are closed under subtraction. Again, we multiply any two rational number, the result, the product, that should be belongs to a rational number. So we can conclude like this, that rational numbers are closed under addition, subtraction and multiplication. But in the case of division, rational numbers are not closed. Why? If we take any two rational number, then divide these two numbers. That should be belongs to a rational number, except the division by 0. Look at the board. 12, a rational number. We are going to divide 12 by 0. What is the answer? Its answer is not defined, or that answer not belongs to a rational number. So we can say that rational numbers are not closed under division. These are in the case of closure property. Is it clear? Okay, once again I am repeating about the closure property. Rational numbers are closed under addition, subtraction and multiplication, but they are not closed under division. Clear? Now let us move to the second property, that is a commutative property. What is the commutative property? For example, add two numbers. Consider two numbers, say A and B. If we add A plus B, then we add in reverse order, that is B plus C. If the two answers are the same, then we can say that they are commutative. Clear? So we can say that addition is commutative. Alright. But what about in the case of subtraction? Is A plus B equal to B minus A? No, they are not equal. So we can say that subtraction is not commutative. What about in the case of multiplication? A into B equal to B into A. So we can say that multiplication is also commutative. But what about the case of division? A divided by B not equal to B divided by A. So these are in the case of commutative property. Let us rewind once again. In the case of commutative property, addition and multiplication of rational numbers are commutative, but subtraction and division are not commutative. Is it clear? Okay. Now let us move to the third property, that is associative property. In order to explain the associative property, we have to consider minimum 3 numbers and 2 operations. For example, A plus B plus C. Associative property says that if we add A plus B and the sum, that is A plus B plus C, if it is equal to A plus B plus C, then we can say that rational numbers are associative under addition. As we know that these two answers are the same. If we have to add 3 numbers, then we can add first 2 plus third one, and the answer should be equal to the sum of second and third plus first. That the answers are the same. So we can say that addition is associative, and similarly multiplication is also associative. But in the case of subtraction and division, they are not associative. Is it clear? So once again I am repeating, in the case of associative property, addition and multiplication are associative, and division and subtraction are not associative in the case of rational numbers. Is it clear? Okay. Now we are moving to the final property, that is distributive property. What is a distributive property? Okay, we are moving to the fourth property, that is a distributive property. Okay, that is a distributivity of multiplication over addition and subtraction. This property says that if A into B plus C is equal to, that is A is a number, that number into a bracket which is equal to AB plus AC. That is the first property, that is distributivity of multiplication over addition. And once again I am repeating, A into B plus C is equal to AB plus AC. That is the first property, that is distributivity of multiplication over addition. And the second property, that is a distributivity of multiplication over subtraction, is A into B minus C is equal to AB minus AC. That is the fourth property. Is it clear? We have to solve some problems using these properties. Okay, so you just rewind once again the distributive property of multiplication over addition and subtraction are A into B plus C is equal to AB plus AC, and A into B minus C is equal to AB minus AC. These are the four properties. Okay, now we have to be discussed some another points, such as role of 0 when addition. What is the role of 0 when we add a number with a 0? For example, 5 plus 0. What is the answer? All of you know that the answer is 5. What about 12 plus 0? The answer is 12. Which means if we add any number with a 0, the result should be the very same number or the identical number. So we can say that 0 is the additive identity. What is the name? Role of 0 is, it is the additive identity. Once again I am repeating, 0 is the additive identity. Clear? Similarly, role of 1 when multiplication. What is the role of 1 when we multiply a number with a 1? 5 into 1. What is the answer? 5. What about 12 into 1? What is the answer? 12. So we can say that 1 is the multiplicative identity. Please repeat. What is that? 1 is the multiplicative identity and 0 is the additive identity. Clear? Now what is a reciprocal? What is meant by reciprocal? If we interchange the numerator and denominator of a rational number, then we will get it is a reciprocal. For an example, consider a rational number 5 by 3. If we interchange the numerator and denominator like this, 3 by 5, then we can say that 3 by 5 is the reciprocal of 5 by 3. Is it clear? What is mean by reciprocal? Reciprocal is the interchange number. That is, if we interchange the numerator and denominator, then we will get the reciprocal. And if we multiply a number with it is a reciprocal. What happened? 5 by 3 into 3 by 5. If we multiply a number with it is a reciprocal, the answer 5 into 3, 15 divided by 3 into 5, 15 is equal to 1. We will get the multiplicative identity. What is that? If we multiply a number with it is a reciprocal, then we will get multiplicative identity, that is 1. That is the importance of the reciprocal. Now we are moving to the final point of today's class, that is negative of a number. What is meant by negative of a number? Very simple. If we change the sign of the number, then we can say that that number is the negative of that particular number. For example, 10. What is the sign of 10? It is plus. 10 means plus 10. That is the sign. So what is the negative of 10? Negative of 10 means minus 10. That is all. So we can say that minus 10 is the negative of 10. Similarly, what is the negative of minus 10? In order to get it is a negative, we have to change the sign. If we change the negative sign, then we will get 10. So we can say that, or we can conclude that minus 10 is the negative of 10. Similarly, 10 is the negative of minus 10. That means, in order to get negative of a number, we just convert it or change its sign. That's all. So, I think today's class is a little bit lengthy. Don't worry. You have to listen today's class carefully 2 or 3 times, and you have to prepare a note for this today's class. That is today's assignment. Okay. I wish you a very good day. Have a nice day. Thank you.